section 4.5, we're looking at changes in ecosystems, and really we're looking at how humans affect ecosystems. So what are some human impacts? So changes in terrestrial and aquatic ecosystems happen naturally over time as biotic and abiotic factors gradually shift. Okay, it makes sense that like we've seen over millions of years these factors change. In addition to natural events such as floods and fires can cause sudden dramatic changes. However, one of the most common sources of change for our ecosystem is our activity, human activity. Okay, different forestry practices. Okay, anytime you take out any trees, you're going to change that ecosystem in that area. So deforestation falls under 3 different categories. So there's slash and burn. Okay, this is used in tropical areas. Basically, bulldozers are just used to remove all existing vegetation. The debris is piled and ignited into a big controlled burn. There's clear cutting. So this is a removal of all trees in the area for use in timber and pulp. So in Canada, this practice is followed by replanting the dominant species of trees. Okay, and then there's also selective cutting. This is where someone goes through and kind of marks off different trees, and then only certain trees are harvested from an area, leaving others to kind of regenerate the ones that are cut down in that area. Okay, the effects of fire. So fire creates and maintains a mosaic of different vegetation types. Okay, such as grasslands, wetlands, shrub areas, and aspen parklands. Okay, fires are actually important. Okay, they help recycle nutrients and make room for new growth. Okay, lightning causes some of these fires to happen naturally. Okay, also now that we've kind of been watching, there are some that are prescribed burns. So this is a controlled fire set intentionally in a designated area to kind of help some of the regrowth happen. Changes in lake ecosystems. So like terrestrial ecosystems, aquatic ecosystems are sustained by dynamic equilibrium among the biotic and abiotic factors. So when we change any of these factors, okay, they can have a profound effect on the ecosystem as a whole. Okay, anytime you change the equilibrium, you have to, if you take something out, you have to add something in. So different types of lakes. There's oligotrophic lakes. Okay, these are deep and cold lakes. Okay, the nutrient levels are low in lakes because if they're deep and cold, they're going to have the smaller limnetic area. Less things can grow there. So it limits the size of the producer populations. Only a few kind of organisms kind of live in there. Usually the water in these oligotrophic lakes is very clear. Okay, eutrophic lakes, these are generally shallow and warmer. Okay, have an excellent supply of nutrients. Species of photosynthetic organisms find these abiotic conditions more favorable, and as a result, this water is often murky because a lot of things are living in that water. Okay, oligotrophic lakes gradually become eutrophic lakes over time. The eutrophic lakes become increasingly shallow, eventually filling in and becoming dry land. Okay, and so basically you can think of like the more living things that are in a lake, the more kind of debris that falls on the bottom, which then builds up, and that's why we get that eutrophic, they become eutrophic lakes and so on. So this evolution from oligotrophic to eutrophic to land is called eutrophication, and it takes hundreds or even thousands of years. Okay, there's a figure in your textbook on page 116 to kind of show you what's happening. Okay, water pollution. Okay, so biological, chemical, and physical forms of water pollution can be grouped into 5 different categories. So the first one, organic solid waste. So this would include sewage, waste from food processing. Okay, as this matter is decomposed by bacteria, the oxygen in the water is used up by the bacteria to decompose all these solid wastes. So, and as you take the oxygen level down, less things can live there. Disease-causing organisms come from sewage and animal waste that enter the aquatic ecosystems with runoff. These organisms can trigger outbreak of waterborne diseases such as typhoid. Inorganic solids and dissolved minerals include waste from mining, fertilizer, salts from roads, all of that when it gets into the water system. Okay, like you think if there's fertilizer, more things are going to grow, but usually it causes more of these disease-causing things, or it'll have more bacteria, which then reduces the oxygen. Okay, so thermal energy from electricity generating plants and other industries. Okay, so thermal energy is, again, we're heating up. So lots of people are like, oh, we're just putting water in the water. But the problem is, like, when you're using the thermal energy, you're heating up the water, you're putting it back into the lake, and then heating up the water in the lake or the river that goes by, okay, which then affects the aquatic ecosystem because as we kind of learned in chemistry, the higher the temperature, the less gases will dissolve. So that will reduce the amount of oxygen in the water. Okay, and then the last one is kind of organic compounds, such as oil from roads, pesticides, different detergents. Okay, road oil is toxic to fish and all waterfowl. Okay, pesticides are toxic to a lot of organisms, which is why we use them. Okay, and they can accumulate through the food chain. So phosphates promote algae growth, which then results in the loss of oxygen during decomposition. So whenever you have this algae bloom, okay, they kind of pop up, but then they die out and need to be decomposed, and it takes up all the oxygen. Okay, and that's why too, like with all of these, you have to think about like how these things get into the water, and you probably think like, I never put this into the water, I'd never put the detergents into water, but remember, like anything that goes down the drain ends up in our water system. Okay, indicators of water quality. So how can we kind of tell if the water quality is good? Okay, a lot of this, like you can kind of just look at water and usually be able to tell what that water quality is. So one is by looking at the bacteria. So chloroform bacteria is a type of bacteria that occurs naturally in the intestines of humans and other animals, and this will indicate the presence of fecal contamination in the water. So if you want to look for that bacteria, you can look under a microscope. Okay, if you see that bacteria, okay, that means that water is contaminated with fecal matter, which would not be very good. Okay, the quality of, it should say, of dissolved oxygen. How much dissolved oxygen is a big indicator of what can live there. Okay, everything kind of needs oxygen, and so the more oxygen, the more biotic life can be there. And then the biological oxygen demand. So this is the amount of dissolved oxygen needed by decomposers to completely break down the organic matter in a sample of water at 20 degrees Celsius over 5 days. So how much oxygen they're going to take up. So the more things that are dying in there, the more oxygen they're going to take up, okay, which then affects everything else. Okay, and so this is kind of just looking at, okay, like how a lot of our stuff gets into our water. Okay, so you have a cabin, you have an outhouse, or nowadays most cabins have their own sewage system or something. Either way, though, how they work is they just basically put the sewage underground and let it get into the soil. Okay, but that waste, then there's groundwater under here. There's the spring water table, so the water kind of is under, it's mixed in with the dirt, and so it brings some of the waste over. Okay, and the bacteria start to break down this waste. The matter is returned to the ecosystem, which plants then grow. Okay, but then it takes a lot of oxygen and stuff, the more things that are in it and the more decomposers. Okay, and so yeah, all our human waste are broken down by bacteria, which then function as decomposers, which take oxygen away from that lake's ecosystem. All right, you can look at the Explore issue on page 120. Make sure you complete your assignment.